Hello everyone, I am Arpan Ariman Behra, a BTech third year student from the Department of Computer Science and Engineering with specialization in Artificial Intelligence and Machine Learning at Sivaraman Global University, Bhubaneswar. I am currently undergoing training under the AI and Data Science program provided by Crane University. I would like to sincerely thank Sivaraman Global University and Crane University for providing us with this wonderful platform to gain real world experience and hands on training through such projects. As a part of this training, I have worked on a project titled BBC News Classification using Word2Vec, which we are excited to present today. In this project, I aim to develop a machine learning model capable of automatically classifying news articles published by the BBC into one of the five categories: business, entertainment, politics, sport, and tech. What makes this task interesting is the challenge of teaching a machine to understand natural language, especially since news content can often be nuanced, complex, and context-driven. To tackle this, I use the technique called word-to-vec, which goes beyond simple keyword matching by learning the contextual meaning of words. This project combines the core natural language processing techniques with machine learning to solve a real world text classification problem. And here are the data sets that we have used, which contains the BBC text. And next, these are the loading of the summarized data set. And here we have cleaned the data set. And in this segment, the dataset I used that is called BBC News dataset. It contains 2,225 articles, carefully curated and already labeled into five predefined categories that are business, entertainment, politics, sports, and tech. To prepare the raw text data for modeling, I went through a comprehensive preprocessing pipeline, which are tokenization, which means breaking each article into individual words. And second one is removing stopwords like the, is, and, which don't carry any meaningful information. Third one is punctuation and digit removal to reduce the noise in the text. And fourth one is lemmatization, which reduces the words to their base of dictionary form. For example, running becomes run. These steps helps in standardizing the text and ensuring the machine focuses on meaningful linguistic features instead of raw unstructured text. And these are the analytics visualizations, some of the analytic visualizations. And next, these are extra visualizations. And in this third segment, this is the what to back feature extraction. Once preprocessing was done, the next step was converting the text into numerical vectors that a machine learning model can understand. Traditionally, this is done using the bag of words or TF-IDF. However, both treat word as independent tokens, which means they miss semantic context. I used Word2Vec, a much more advanced technique developed by Google, which learns distributed representations of words by looking at their surrounding context in the text. So if the word bank appears near the words like river or money, Word2Vec learns to differentiate meanings between on those contexts. Once each word is represented as a vector, I calculated the average of all word vectors in an article to represent the article as a single vector. This process preserves the semantic structure of the article while giving us a fixed length feature vector perfect for feeding into a classifier. And this is the code for them. And here is the training of Word2Vec model. And here is the vectorizing of the text. And in this segment, we are evaluating the random forest classifier. And here is the confusion matrix for random forest. So here we classified the summarized data using the random forest. And this is the confusion matrix between Word2Vec and random forest. So in this last segment, uh, with our feature vectors are ready, the next step was training a classification model. I chose logistic regression, which is a widely used and interpretable algorithm. Here is how the pipeline look. Split the dataset into training and testing sets. Training the logistic regression model on training set. Evaluated it using metrics like accuracy, precision, recall, and confusion metrics. The results were promising. The model showed high accuracy and balanced performance across all five categories. This proves that even with a relatively simple model, using rich contextual word vectors like those from Word2Vec can significantly boost the classification performance. And this is our total project, the code of the project. Thank you for listening and thank you.